All right, so this is a summary. I'm going to give you kind of a summary, and it'll be just on this one page here of Gaussian elimination, the goodness that it is. Right, this is a big setup. You have to get this stuff into your head coldly, and from there we're going to do a lot more things. But this is really, really essential. So these are pieces I've constructed elsewhere. So all right, so we've got we're solving systems of linear equations. That's the job, right? Boom. And usually we always write as m equations in n variables. We've seen how that translates into a matrix problem, ax equals b, and that's a little summary for this, right? So that's our job all the way through this first section of the course, right? It's the first third of the course, roughly. So there are three pictures. There's a row picture, so we can understand it in lower dimensions, 2 or 3 dimensions. Fine, lines intersecting and so on. And that's actually how we solve things, right? We do work with rows. So it's like simultaneous equations. If you've worked with those in the past, we're always doing that. That was a Roomba, just either saying it's dying or it's finished. Interesting device. So let's see. So that's good. Column is for understanding. We do very well with columns, right? Because we can, and I'll have these below. There's some amplitudes. The x's become amplitudes attached to signals. So it could very much be breaking music down into sine waves or something like that. I mean, it's a discrete version, but we're trying to think of sort of nice examples. So, but music is good, right? So we have different instruments. We have an orchestral sound. We're summing them up. And then the matrix is a deeper understanding. It's a different thing. So we get that. We get to that later on, and there we start to think more of, and this will come soon as well, but some elements of this will come soon. We think of matrices as gadgets, right? Things that rotate, translate, and so on. Every video game or animated picture where there's some movement of something, then there's a matrix behind it, rotating it, and so on. Possibly in our heads, but let's see. So there's a little 2x2 example that we've already gone through. There's the row picture, right? So it's 2 simultaneous equations. We turn it into a column picture, so it's good to know these things. And then a matrix picture, right? So here's A as a gadget. Here we're summing columns to get another column if we can. And the row picture is there. We understood it to be 2 lines intersecting each other potentially, maybe being parallel, so on. Gaussian elimination, we have this very stylized way of doing it. We're really trying to go from ax equals b to ux equals c. This may be right. And so here's just the solution. You can go through this if you want. We have this very nice thing where we turned it all into an augmented matrix problem. So that's on the left here. You have a little example with equations. On the right is the augmented matrix version, which is much better. And we always use this nice form, right? So I'm so excited about that I may just whatever. So there's the right R2 prime equals R2. This stuff is always there, just to accentuate this. And then there's always something in brackets like this. It's a ratio. That's always there. This 2 is here, -1. This is the multiplier L21, so in this case it's -2. And then on the bottom we have D1, right? That's the first pivot, equals -1 equals the first pivot. Very important. Okay, this word we'll come back to. Echelon form means it's staggered, right? In a staircase kind of structure, but it's upper triangular is what we were going for. And so we have a U, right? This is a U matrix. A gets transformed into U, B gets transformed into C by row operations, principled row operations. Not included here are potential row swaps. And that's easy to solve with back substitution. So here's just another example to think about, right? So we turn it into an augmented matrix problem. Here are these nice structured pieces here, right? So here's our original problem, right? It was originally 2x1 minus 3x2 plus 0 equals 3. 0x3 equals 3. So that's our augmented matrix version. We're going to change one row at a time. We always use this form. The multiplier is everything in here, so the multiplier here is actually 2. Let me write that in. Equals 2. It's 4 divided by 2, it's 2. This one is 1, and this one is 2. It's not equal to minus 2. That's not true, right? The minus sign is very important. That's a feature. So everything in blue is always fixed. We always do it in this way too. We always say we change row 2 to a new row 2 by subtracting something off from it. We always work down the first column, then work down the second column. That means that our first bunch of them will be based on row 1, and then the next ones will be row 2, next ones will be row 3, next ones will be row 4, depending on how big the matrix is. And we are slowly eliminating these things. I should get rid of this one. So let me add that annotation. So this is the first one, this is the second one to go, and this is the third one to go. And we're trying to get to this form. Right? So we've multiplied, you can do more than one at once, but we're just going to do one at a time. So this is row 2 changed. Row 2 is the only one that changed here. Right? And we introduced a 0 here, so that was exciting. And then we're going to change row 3, right? So we're moving our way down. So we're going to change row 3. That's this next piece. Boom, gets rid of it. So again, the pivot 2, right, is on the bottom of the multiplier. The number you're trying to get rid of is on top, right? So the 4, 4. 2, 2. That's the number you're trying to get rid of. And then we've cleaned up the first column. We go to clean up this column, and we're going to use this pivot, which has been uncovered. The pivots are slowly uncovered. The pivot is on the bottom here. This number 2 is on the top. And then again, we have that minus sign. So that's going to clear up. We do that act, and we get rid of this 2, becomes a 0. All of these have been eliminated. And now we've got an upper triangular matrix, just to reprise everything, and just to say these are the pivots. This is D1. The first pivot is always there unless there's a 0. You have to do a row swap. D2 and D3. Right, and we've got our multipliers. The multipliers, again, they have a secret purpose that will come back later on. We are doing row operatorification, and we get ourselves into a triangular matrix. So know this stuff, perfect. That brings us to the next section, which will be doing all of this using matrices, right? So we'll actually do row operations using matrices, which, this is really how, this is a big part of how you should do it. You should be able to do the elimination matrix, what we'll call elimination matrix approach as well. It's all connected, everything's connected. Okay, good.